Okay, so we're just going to finish up section 1.6, right? That's what we were doing on Wednesday. Good, yes, 1.6. And I wanted to look at one application because throughout the semester so far, anytime we talked about something new, we then look at applications of it because we want you to see how this stuff is actually useful. So we want to look at what's called work rate problems. And easiest way to work with these, like some of the other applications we've done, is to just kind of set it up and work through it and see what's going on. So suppose we have this. I can grade homework in 3 hours. Speaking of grading your homework, it appears, based off my schedule so far this semester with the combination of the 7 classes plus the meetings I get to go to all the time, your homework's probably going to be graded over the weekend every week, so you'll give it to me during the week. I'll grade it over the weekend and give it to you the following Monday. You guys good with that? Yes? No? Some people complain about it, so I'm just letting you know now. It's part of the deal with all the classes I teach. Okay. I can grade homework in 3 hours. My TA, I do not have a TA, but we'll pretend, can grade it in 6 hours. Because let's face it, TAs are lazy, and so it'll take them longer. Okay? If we work together, how long does it take us? I can grade homework in 3 hours, my TA can grade it in 6 hours. If we work together, how long does it take us? Could anybody give me a guess as to what my answer should be? Without even doing any math, just a guess. What? 4 hours? 4.5 hours. 4.5 hours? Okay, good. That's actually why we're doing this problem. I can do the work in 3 hours, right? My TA is slower, they take 6 hours. If we work together, why would I get 4 hours or 4.5 hours?
Each of you would wind up doing half the amount of time.
No, actually, if I can do it in 3 hours by myself and somebody helps me, then in theory it should go faster, which means 4 hours, 4.5 hours doesn't actually make sense. I'd actually be working slower. Essentially, if you think about it, if in the real world, if me and my TA are sitting there, I'm sure you all have some type of job of some sort, or have had, or will have, or have done some type of work in your life with somebody else. What happens? You have a big stack of work to do, you split it in half, you both start working on it, and it quickly becomes apparent one person's working faster than the other. So you finish your stack, and what do? Do you sit there? No, you grab some of their work because you're going faster, and you go faster that way. So yes, the point here is your answers have to make sense. 4 hours doesn't make sense. When we solve it, we should get something less than 3 hours because it should go faster than me by myself. As far as setting these up, these can be a little bit tricky, so we're going to go back to what we did before earlier this semester and kind of set up a table. Once you understand how this goes, just like the ones we did before, you can set it up pretty quickly without the table. But to get the idea, we're going to do that just to kind of see what's going on. Let's see, we're going to do this. Time to complete the work. And then over here, we'll put me, the TA, and then us together. So, you guys wait that out. I'm going to turn this down. Oh, sorry about it. Is that better or worse? You guys are going to go to sleep if I do that. Well, I'm here to sleep. I had a class like that one summer on computer programming. The instructor thought it would be better, since it was hot and nighttime, to turn the lights off while he taught. Great sleep in that class. Okay, time to complete the work. How long does it take me to complete the work? 3 hours. That's 3. That's easy. My TA? 6 hours. Us together?
Unknown.
That's what we're looking for, so call that X. Now we need another column. Because when we fill out these charts, we always need more columns. This one, we're going to use work completed in an hour. Essentially, the idea mathematically, we are working at two different rates of speed. I go one speed, he goes another one. He's going slower. We need to find a way to compare those. So in math, you kind of do what's called normalize something. In this case, you find a constant time and see what you both do in that time. So for the purposes of this, how much work do I get done in 1 hour? Huh? 1/3? Sure, it takes me 3 hours to complete. In 1 hour, I get done 1/3 of it. How much does my TA get done in an hour? 1/6. How much do we get done together in an hour? That's always the box that confuses everybody when it's time to do it.
1/3
Nope.
times 1/6.
There is a pattern to this, which is actually why we set it up this way. I do 3 hours of work. I do the work in 3 hours, so I get done 1/3 in an hour. My TA does the work in 6 hours, he gets done 1/6 in an hour. Together we do the work in X hours, we get done 1/X. It's just a reciprocal, always a reciprocal. That always confuses people, but there's a nice pattern here. You can see the pattern works great. But now if we remember doing the tables we had before, once you have all the information in the table and we have a variable, you should be able to come up with an equation. And now that we've normalized our rates, we can. If you take the amount of work I do in an hour, which is 1/3, plus the amount of work he does in an hour, which is 1/6, that has to equal the amount of work we do together in an hour, which is 1/X. Now just solve that. We solved these the other day, right? First step, find the LCM. What's the LCM?
6. 3.
All my denominators. What's the LCM of 3 and 6? 6. But there's an x. So the LCM isn't 6, it's 6x, because we have to get rid of the x too. So multiply everything by 6x. Again, at this point, I'm sure you can do all of this directly and quickly and not have to write it all out long form. I'm going to write it out long form. So you get 6x times 1, that's 6x over 3, plus 6x times 1, 6x over 6, equals 6x times 1, 6x over x. Here, 6 over 3 is 2, so you get 2x, plus 6 over 6 is 1, so that's x, equals 6x over x, the x's cancel, and you get 6. 2x plus x is 3x, 3x equals 6, so x equals 2. And in this case we're talking about time, so that's hours. Does that make sense? Yes, I can do it in 3 hours, he helps me, we get done in 2 hours. Get the idea? You will see problems like this in your homework, and you will see it again on exams because they're standard applications, the interest ones, the distance ones, work rate ones, mixture problems. They're all standard pre-calc algebra type problems to see if you fully understand what you're doing. So ponder this, go over it, make sure you can solve problems like it, because you will see stuff like that again. Any questions? And if nothing else, always check your work to make sure it makes sense. That does. So I'm guessing we got it right. I think my math is okay. Good.